Hello, my name is Badru Senoga and I'm here to present EDA for our project, Railroad Predict Model. So number one thing we need to know is exploratory data analysis is an approach to analyze data using visual techniques, and this will help us to discover trends as well as patterns with the different data that we are having. So you see from our Jupyter notebook, the code, we import libraries. That is, you can clearly see the label encoder, which has sklearn.preprocessing import label encoder. It helps us in cleaning this data and converting it into a form that will be easily understood by the model. Then we have the seaborn as well as matplotlib. These ones will help us when it comes to showing graphs. Then we do have the profiling, whereby it will be able to show us the statistics that are within the database or that are within our data set. So from there, we do have the option whereby we shall go ahead and import our data or read our database or data set. So from reading the data set, this is the link where I stored the .csv file. That is the data set that we are using, and our data set contains, as we are going to see, it's about how patients are responding to line 1 or line 2 drugs, that is the ARVs, and that we need to find a way, is it suppressed or is it responding to the drugs, or it is drug resistant. So profiling, it will help us to show us all the details about the data set, and of course we'll be able to visualize it, see the overview, data set, variables, the districts. So it breaks it down to data that can be easily understood instead of figures, the interaction and the correlation between the different information in the data set, even the missing values, samples. So that's it. So the head, it just shows us some of the information in our data set that is at the top, and as you can see, we are going to be using unique ID. Then we have the current regimen is like treatment or medication, and then result alphanumeric, it shows the number of copies of HIV in the blood sample, in the milliliter of blood. And then suppressed is the one we show us if a person is represented with suppressed as 1, it means that they are responding to the drug treatment. If you see 2 or 3, it means they are not responding or not suppressing to the drugs that are being given. So suppressed will be used as our independent variable, and then we shall be using current regimen as our independent variable. So type simply helps us to show the type, the examples that are in column, how are they like. You see, simply breaks down some of the examples that we are having. So we just need to clean this information and be able for the model to be able to use it. So we are going to use current regimen. As I said, it is just about being able to know, it's about the medication, and you want to know whether the HIV patients, they are able to respond to it or not. So from the label encoder, it simply cleans our information or converts the data, let's say numbers and digits, and then you convert it to whole numbers. In case you have words and digits and you want to convert it to whole numbers so that the model can easily understand, let's say male and female. So you see under gender, it is now 00. You see zeros and then twos. So whether male or female, it converts. So in a way the model can easily understand. The same applies to treatment duration. It has changed, as well as the current regimen has changed. So it's simply in a way that is easily to be understood by the model. So where you see the option of here under current regimen, where you see one, this shows that they have just started taking the treatment, and they can still respond. They are still resistant, so they are still responding to the drugs. But these ones where you see the ones that are below, they are the ones we are looking for, whereby they have value as 1, 1, 1. Here they are not responding to the drugs, and that's why we are having a combination of drugs here, as you can see, because they require combination since they are not responding to the drugs. Okay, so encoding, it is just converting, whereby it will help us in doing the analysis of the heat map, and then it will also help us convert the values to the information to binary values. So our regimen, our gender is also converted to ones and zeros, and then we are able to go ahead and use this information in our model. Okay, so yes, so all this data will have to be clean. We don't need to use all of this. We shall just use a few details. Gender here, it is showing 0, 2, 1. Sometimes you can put a female with a capital F, then male with a small m, like that, but we are going to rectify that. So correlation, that is just for the heat map, and then just give us a graphical representation. Symbol, it helps us to easily be able to represent the boxes clearly, whereby you see that right now for the box plot, it helps us. Of course, we defined our x variable as the suppression, that is the x variable, and then the y variable is the current regimen. So we want to see where you see a 1 is for people who are suppressing. There's this one, the one that is not having any block. Then where you see a 2, those are the ones that are between suppressing and not suppressing. And then where you see the 3s, these are the ones that are not suppressing at all, meaning they are not responding to the drugs. So as you go on and you see this option of the heat map, you see that clearly where you see this one, it is the boundary whereby it can show us, it is showing us the maximum suppression. And so from, as you see, there are those ones that are a little bit dark purple, and those ones that are not. So where you see dark purple, where it is least intensive, so there is no suppression, where you see 0.0. As you go up on the bar, as you go up to the area which is yellow, that is 1.0. so this is where there is most intensity, and the people here, they are over suppressing. So from that, we are able to see the scatter library as well. It helps us to be able to represent the data. Of course, current regimen with suppressed, it's another form of representing data, and it helps us to, you can clearly see the outliers, the ones that are on 3.0. so here we split, we declare, we get the variable that is x equals to suppressed, then y equals to current regimen. So we split the data according to those two variables, and then we go ahead and call the library that is to train test split. So when you call it, we declare these 4 variables, that is x train, x test, y test, and then you go ahead and be able to run the length of the y train, that is it, because here we split our test size to 0.30, meaning the training size is the one which is 70%. So according to this flow, if you see this table, it is having over 1 million, then 48,575 rows. So when you divide this data, test data will be 30%, then the training data will be 70%. So that is around 734,002. So when you go ahead and we call linear regression as our model to test, we are able to train the model. You see that here we call again, and we are able to use it to predict the x. Okay, so you go ahead and you use it to predict. It gives us a length of y train colon. So as we saw, so here even for the x test, it will give us the prediction. Then what we need to do next is to go ahead and fit it to any of our models, and we can fit the x train as well as the y train into a linear regression model, and this is what it gives us. The score is not so good, 0.003. Okay, so we see we are doing, of course, after using that function and to predict, it gives us a value that is not close, because the prediction of x test and the prediction of y test, they should be, at least the values should be a little bit close, but here we can see they are they are not near each other, so meaning even the score may not be accurate, and we need to find a way. So we can do the tune hyperparameters to be able to improve our score or our performance with this particular model. So okay, so I applied the concept of randomized search CV, whereby it goes through a fixed number of hyperparameters setting within the grid, and then we are able to, of course it is in a random fashion, and we can find the best set that can go ahead and after finding the best set of hyperparameters, we can go ahead and get a better performance in terms of score. Here I was able to instantiating the decision tree classifier. First did the creation of hyperparameter grid, then instantiated the decision tree classifier. Then after that I was able to go ahead and instantiate randomized search CV object. Then from there it was able to print for us. So you realize here, apart from these hyperparameters, we are able to have a best score, which is 0.71. That is around 71%, which is not bad, but still we can apply more other models to get a better performance.